a company needs to deliver a shipment of posters. The posters are stored in cylindrical cardboard cases. So we've got lots of tubes of Pringles if we're thinking about a cylindrical container. That's not a good start, is it? So we're down there and we're going down there. So we've got some bit squeezed at the bottom, but that's what we're looking at. We're looking at a tube of Pringles, but this is a cylindrical cardboard case. But picture a tube of Pringles for this purpose, because a tube of Pringles has got a lid that comes off. That's that part. Okay, the bottom part don't come off, but if it did, it'd look like that. So there'll be top and a bottom. Okay, and then what's left is this part here. If we were to unwrap that like a packet of Rolos, so we're going to take the Rolo wrapper, not the gold wrapper off a packet of Rolos, but the brown part of a packet of Rolos off, and we're going to literally put it flat on the floor. Okay, what we're left with, we've now unwrapped our tube of Pringles into 3 different shapes. We've got the top and the bottom, and the bit that wraps around the actual tube of Pringles, but when we unwrap it and lay it flat on the floor, it becomes a rectangle. And this distance here is actually the difference, the circumference of our circle. So as much as we don't know that yet, as in like the actual what it is, circumference of circle, likewise at the bottom. And then it says here the height is 1.1 meters tall. But everything else is in centimeters. So for 1.1 meters, I'm actually going to say it's 110 centimeters. That's what it is when it's converted to centimeters. So we've now got 2 measurements. One we know, 110. One we don't, circumference of a circle. To find out the area of our Rolo wrapper, or the bit that goes right round the cylinder. And so we've got here the radius of that circle. So from the midpoint out to the side is 3 centimeters. So all the way across has to be 6, because the radius is to the midpoint, the diameter is it travels right through from one side to the passing through the midpoint. So we've got here diameter and radius. I've got everything I need now. I've pulled everything apart from that question, and I've got all the dimensions that I actually need. Oh, it says pi. So pi, it says use 3.14. Once I've got all my measurements, I just need to do the math. These two, I need to find out the lid. So the bit that goes on the lid, that becomes the area. So I need to go area, and I'm going to try and color it in as best I can. Area, not the crust, the area of a circle. Area equals pi times by radius squared for my lid. That's the bit that goes on top of my cylinder. But I've got 2 of them, so I've got a bottom as well. So once I've found out that, I'm going to times it by 2, and I'll have the right information. So let's get our calculator up, because it's a calculator question. And I think we've got everything we need. So let's have a look. We're going to move my calculator over to the side. So pi, and it says for pi in this question, use 3.14. Yeah, times by radius squared. Okay, so 3 times 3 is 9. Okay, so we're going to times our pi by 9. 28.26 for one lid. That's the top bit. We need the bottom bit. So we're just going to times that number by 2. Times by 2. So we've now got the lid equals 56.52. If we imagine your tube of Pringles, you've got the plastic bit that comes off the top, the clear bit, and then you can't take the metal bit off the bottom, but you've got the bottom bit. So you've got the very top and the very bottom. Now we just need to work out the wraparound, which we've unwrapped, and it's a flat rectangle with an upward part on the side of 110 centimeters, and the other line is the circumference of a circle, because it goes all the way around the circle. To work out the circumference of a circle, we're going to scroll down a little bit more. So we're thinking crust now, and I know my circles are getting worse. We've got pi times diameter for our crust. So circumference, circ. And we've already got pi because it told us what pi was, 3.14. And we know that diameter is double the radius, and the radius was 3. So the diameter is 6. So 3.14 times by 6, 3.14 times 6 equals 18.84. That's not the answer we're looking for when it comes to the Rollo wrapper, or the bit that wraps around. That is the second distance or second measurement that we need for that wraparound bit. So our circumference of our circle is 18.84, and our height of our circle is 110. So if we multiply those two together, we've got all the area for that square. I'm not going to color it because I think I'll make a mess. So we've got our circumference at 18.84 multiplied by the height of that circle, 110, and we've got 2072. So 2072.4 for the wraparound Rollo wrapper. Imagine it's been a packet. That's the only thing I can imagine. Obviously, 110 is bigger than a Rollo wrapper, but when I take that brown wrapper off a packet of Rollos, it becomes a rectangle, even though it's been around my cylinder. So that's my Rollo wrapper, 2072.4. That's my lid and my base. So I add them both up. Add 56.52 equals 2128.92, and the correct measurements is centimeters squared, and it's squared because it's flat. It's flat. It's all around. It's if we had 1 centimeter squared stickers, we've got to stick them all over that cylinder. We'd have to have 2,128. Well, 2,129 because we have a little bit left. But it's not volume. We're not talking inside. We're not talking the number of Pringles inside our tube. We're talking all the way around it, lid, base. Hopefully, and give your answer to 1 decimal place. So 1 decimal place would look at that, and we'd see that's a 2. So it remains at 2128.9 centimeters. Oh my gosh, now I'm writing cubed. Squared. I wrote squared above it. So how I suddenly changed to cubed, I don't know. Okay. Hopefully that is allowing people to see the breakup of our cylinder. But what I'll do, I'll save that. I'll send it out when I come to send out the recording of this session, so people can see that that question on assignment 2, I think it is, on atom. Right, let's get rid of that one like that. And what I was going to do is look at, again, area, volume, and surface area. If I make it into big, I'm hoping I can draw on it. I'm not entirely sure, but I'm hoping I can. From the beginning. Okay. Right, I'm going to get off the screen. All right, can I annotate? Annotate. Here we go. Could be tricky. Right, I'm hoping. Yeah, only I can annotate. Yeah, that's fine. All right, please. Why is my pen not? Oh, okay. I don't even. I'm not a big lover of red, so I just need to change that. Oh, purple's not gonna be good on there, is it? I'll have to do green. Okay, green is go. Let's go for green. Let's rub that bit out first though, because I don't want that on there. Okay, so we're going to look at some questions as well as figuring out what area, volume and surface area and volume actually means. But this was a question. What I try and do when I'm doing my subject lessons is have a question today to start off with that was based on last week's session, or one session from last week. So if we're looking at scale, don't worry about the reverse calc, but if we're looking at a scale drawing, it's saying at 1 centimeter on the map. So 1 centimeter, one. Oh, that's a bit fat. Don't like that one. Let's make it thinner. Okay, 1 on the map. So map, yeah, that's better. Is the same as 20,000 in real life. So 20,000 centimeters in real life. So if we say there's 100 centimeters equals 1 meter, and then 1,000 meters is the same as 1 kilometer. We can shrink this number to.
Sorry, we can't see anything on there.
What? What? Any writing or any screen at all?
Yeah, I can see the screen, but I just can't see the writing.
All right, it's gone. All right, it's gone. Where's my writing? I just wrote. Right. What happened there then? Let's have a look. Annotate, right? Right, it's annotating, it's thinking about it. How bizarre. Now I can't annotate, right? Annotate. Right, why is it not letting me draw on it now? Can you see red?
Yeah, I can see the red.
Right, let's stick to red. Let's not worry about anything else. Right, so and I didn't want to draw that. So I'm gonna have to draw up here now. So 1, right, on the map. I'm drawing in the top right hand corner now. So
yeah, I can see now.
Right. That's weird, isn't it? Because I changed colour and everything. Right, in real life.
I thought about my eyesight, and I've got glasses on as well.
Yeah, I'm doing it in camouflage blue, so you can't see it. It's the same as 1 meter, and then I said 1,000 meters is the same as 1 kilometer. So what I was saying is that if it's 1 centimeter on a map, that means 20,000 centimeters in real life. I can't visualize 20,000 centimeters. I just can't. It's, well, every centimeter is like as long as your thumb. So thumbnail, 20,000 I just can't picture it. So we're going to divide that number by 100 to figure out what it is in meters. If we divide a number by 100, we just take off 2 zeros, or we move the decimal place 2 places in. So I know on my map it's the same as saying 200 meters. So that's more like it. I can visualize 200 meters. Usain Bolt running twice. Yeah, once and then again. So I can see it. Now, 1 centimeter on my map is 200 meters in real life. So I've kind of figured out what that's saying. Find the real distance Annie has to walk from point A to point B. Give your answer in kilometers. Okay, so it's saying nine of those. So we're looking at that number there. That's 9 times bigger. So that has to be not 7, 9 times bigger. So 9 times 2 is 18. So 9 times 200 becomes 1,800. So we've now got a distance of 1,800 meters. It doesn't want it in meters, it wants it in kilometers. But we know that there's 1,000 meters in a kilometer. So if we divide this number by 1,000, by 1,000, we're moving the decimal place 1, 2, 3 dp. So we'll start here 1, 2, 3. So we got 1.8 kilometers. So when we're talking about scale drawings, obviously they're not all, well, they're never really worth that many marks. And the reverse calc is definitely something that Pearson asks for more than NCFE. NCFE don't really worry about the reverse. If you've got there, they're happy with that. You don't have to work and go backwards. So we're not going to look at the reverse calc here. The reverse calc will be just saying go backwards. So we can say 1,800 divided by 9 equals 200. So you just got to work backwards, which is a bit strange. If you're going forwards, why confuse yourself and go backwards? So we know that the distance that Annie's got to walk is 1.8 kilometers, and that'd be worth 3 marks. Again, don't worry about the additional mark for NCFE. They don't have reverse calc. So for 3 marks, we've gone up in real life to show what it is in centimeters. Yes, and we've shrunk it down to what we know. Then we worked out the real math and said it's 1,800 meters. And then for the third mark, we've put it into the units that they've asked for. Hopefully that would work. We're looking at perimeter and area. We should know that perimeter is, I always think of the word perimeter as, I'm not in prison. I'm at home, I promise you. Perimeter fence, okay? And then when I'm in area, I always think it's like the area that they're allowed to kind of mill around and do the gym in. So I'm going to call it play area. I know if I was in prison, I call it play area, I probably wouldn't be very popular. So I've got my perimeter fence and my play area. That's how I remember the difference between perimeter and area. If it's a perimeter, I've got to build a fence right round my shape. If it's the area, it's where I can play. That's all I need to know. Because my perimeter is adding, because I need to add up all the bits in kind of in succession. Whereas my area is multiplying, because I want to know, I need to know my distance, my length and my width, and then times them both together and find out what's in the middle. So once I've figured out perimeter, area, the two differences, I then remember, oh yeah, perimeter is adding. And the good way to do perimeter is if we start, I'm going to start walking here. Some people start somewhere else. I always try and start bottom left. Again, I don't know why, just something I've always done. I'm going to walk up and I've got 9. I'm going to walk along. I can't do that one because there's no measurement. So do I not count anything? Absolutely not. We know that the full distance is 8, and this mini distance here, and it's not to scale, as you can see, the mini distance is 3. So the bit that's missing has to be 8 take away 3, and therefore 5. Why is it doing that? 5 centimeters. What? Now M's disappeared. Okay, now I've got them in there. Add 5. And the bit the same here, look, it don't tell me what it is, but I don't miss it out. You don't just add the numbers up you can see. You need to make sure you're going on all the distances. So the main one is 9. The little one is 3. So that makes the missing one, 9 take away 3 is 6. So I've now got 6. Add 6. Add 3. I can see that one. Add 3 again. Add 8. And I'm back to where I started. So my perimeter for this one is 14, 20, 26, 34 centimeters. And it's not squared, it's not cubed, it's just distance, centimeters, no little number after it, because we're just walking in a straight line. Well, we've turned corners, but we're walking, we're not having to kind of create an area. Area absolutely is centimeters squared. We'll do the perimeter of this one as well. And I'm hoping that you're looking at this and thinking, yeah, I could do that. That's quite easy, Steve. Because again, we've got to walk all the way around. We haven't got a distance to start with, but we can see that the one on this side, I mean, it's meant to be the same, which is badly drawn. I didn't draw, my drawing is bad, but even I can see that's not level with that. So when they drew this, like, come on, but that's going to be 5 as well. So that's 5. So I've got 5. Okay, starting in bottom left again, I'm adding, I've got 4. And I've got an upwards one. Oh, there's no measurement. Okay, I know it's 4 on the other side, so that's 4 as well. 4. And again, I know it doesn't look, I'm glad it says not drawn accurately because it's terrible. Then we've got a big one along here. Oh, we can see it's 4 to about there. Then another 5, and then another, oh, I don't know that one either. What's going on here? How can I do that one? Oh, it says 3. It says 3, but it's on the inside. So don't worry about that. It's on the inside. So we got 4 and 5 and 3. So 4 and 5 is 9, and 3 is 12. So we've got the long bit along the top is 12. I'll put it there. So we've got 4, and we've got 3, and we've got 5, then we've got another 5, and I'm back to where I started from. It looks like there's a lot of measurements there. If you're not sure, or you think, oh, have I gone one too many, just walk around again, but don't count the measurements, count the sides. So 1, 2, 3, 4, 5, 6, 7, 8. I should have 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. I'm okay. I've got 8 numbers. And if you think you only got 7, like, oh my God, which one have I missed out? Walk around again and find out. With perimeter, it's a walk around the outside. So we're going to add these up. That's 9, 13, 25, 29, 32, 42. 42 centimeters. Area multiplied. We're looking at the area of these. We got lots of different ways to do it. I could put my little line down here. Yeah, and work out that square, then that, well, that rectangle. I could put my little one across there like that. Yeah, and then do that one and then this one. I don't know how, again, or some people will make it into a big one. Well, yeah. And then take away that bit there. There's many ways to work out the area. If this way, if the big way is your way of doing it, okay, we can see that the full length here is 9 and the width is 8. So 9 times 8 is 72. But that's not the area, is it? Because that would include that part there. Then we've got to look at this bit here is 3 by 6. 3 times 6 is 18. And we've got to take that 18 off of our 72. So take away 10, that's 62. Take away 8, we've got 54. Okay, so some people do it that way, where they think, imagine it as one big shape and take off the bit that they don't want. If that's your way, that's absolutely fine. I tend to break it up into 2, so I don't need to do any takeaways. I just do adding. So we're going to look at, take away the donut so I can know it's 54. Okay, we got it. 54. I'm going to separate them. So I've got this shape here, and I'll put little circles in that one, just so you know I've done different ones. Right. My squiggly box is 8 times 3. So 8 times 3, squiggly box, 8 times 3 equals 24. Okay, so my pen's a little bit behind. It's like my internet's slow, I don't know. And then I've got not 9 times 5, because 9 would be all the way down, but I've got my 6, my one that I found out, 6 times 5. Right, and then add them now, because I've got my 2 actual bits. And it's fine. I'm not saying takeaway is difficult, but adding is so much easier. And 24 add 30, 54. So we have got the same answer. Oh my gosh, what's that one there? Centimeters squared. Because that's the bit in the middle. How about this one? I mean, I feel embarrassed that whoever's drawn this that actually works for Pearson, because I can, wow, I just don't get it. It's miles out. All right, I'm gonna, again, could we do the whole thing? Absolutely, we could. It's a bit more difficult because we've got 2 spaces to take away, but we'd have 12 times by 4, add 5, 12 times 9. We could do it that way, or the better way, well, not saying the better way, I'm gonna go across there and I'm gonna do the squiggly bit and then the dotty bit. Oh, my dots have come. Chicken pox have arrived. Okay. All right, so my squiggly bit, it's 12. Because I did it before, I worked that bit out. 12 times by, and it already tells me it's 4. 12 times. Oh, yeah, it's going. I did do another one. All right, 40. It is really, really slow. 48. And then my bottom bit, I can see it's 5 because I got one measurement there, and I can see it's 5 again. Oh, this could be really annoying. Right, and then add them both up. So that's 68, 73. Well, yeah, that's something. Mirror. Right. Oh, easy. So 73 centimeters.
Hello.
Oh, hi, Miro. Are you all right?
Yeah.
Well, my screen is right. I'm trying to write centimeters on there, and it's not letting me. Centimeters squared. So area of the two shapes we've checked out. Doing it two ways, working out the big square and taking off the little one, or my preferred method, and it's only my preferred method, is breaking it into two smaller shapes, adding them both together. This one, again, we did the two small shapes together. Had we done the big shape, yeah, we do 12 times 9. 12 times 9, so we do 12. 9 times 10 is 90. 9 times 2 is 18. So 108 for the full shape. And then we take away the two spaces that we've got left in between. Right, have I done that right? Brain's now thinking I didn't do it right. 12. Oh. Whoa. Okay. So we've done two different ways. We've got the answers here. Look, we can see that we've got both those exactly right. And we just did it two different ways. Is area and perimeter something we get mixed up a lot, or is it something that we're happy with? Area and perimeter, it should be fairly straightforward when we're looking at the perimeter fence right around the object, or the area we play in. That's the difference. Right, why is that not letting me do it? We're thinking of pyramids. We're thinking of a football. And don't forget, when you get a pyramid and a football or a sphere in your maths, you will be given the formula. Rubik's Cube, you won't be given a formula. Volume, base, times height, times length. My favorite, tube of Pringles, you won't be given the formula. We work out the area of the lid, the area of the base, add them together, and then we unwrap the roll around bit to make it a flat wrapper. We work out the circumference times by the height, and we add our two bottoms, our top and the bottom, together with our wraparound bit. You definitely won't get a formula for a cuboid. That's a rectangle again, base times length times height. And a Toblerone, you will get the formula for. So you're going to get the formula for 1, 2, 3 of those, and you won't get it for 3 others. I like talking about food because I think food and maths is pretty good. If we're talking, I want to get to not that screen. I want to get to the proper screen where it gives you. If we're looking at shapes, lots of people. I'm going to actually show you the answers rather than go through it. If we're looking at shapes, sometimes, I mean, I think there's been one question where I've been asked to identify a shape on level 2 in the last kind of the 6 papers that I've got. And then there's been a one on level 1 where it's asked me about faces of a shape. If we think about faces of a shape, then that's what we see, the different faces of a shape. So faces is pretty straightforward. If we're talking about vertices, I would relabel well, I'm not, but if I was the mathematical professor that created the word vertices, I'm creating the word corner instead. Because vertices, I'm not brilliant at English. I don't claim to be, but for me, a corner, it makes more sense. 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 corners. But vertices is basically where 2 lines come together. And again, that would have 8. Cylinder obviously has none because it's got no pointy bits, no corners. But how do I know it's got no vertices? I don't really know what the word vertices mean. I know what corners means. I know that's got no corners. I can clearly see that with my triangular prism, my Toblerone. I know it's got 6 because it's got 3 there and 3 on the other side. So I know that vertices is 6, but corners is easier to remember. And the sphere, I've got no corners. I've got no vertices. So again, it's so much easier. And edges just means lines. So I wish I could. How many lines does your cuboid have? I'm all right with that. I've got 4 there. I've got 4 on the other side, and I've got 1 there, 1 there, 1 there, and 1 there. I've got 12. Oh, I've got no lines on my sphere because it's never ending. It's not got any lines. And why has my cylinder only got 2 lines? Well, it's got 1 around the top where my lid comes off my Pringles, and 1 around the bottom where my base comes off my Pringles. So yeah, lines, edges, and vertices, corners. That would be my only advice when it comes to if we've got a shapes question. You're not going to get anything more difficult than what you see on this screen here. You might get asked to identify one of these shapes, and it'll have 3 or 4 different answers. So that should be really straightforward, because a cube has to be like a Rubik's Cube where all the sides are square. A cuboid, I always think of it as being a packet of cereal. So I've got different size rectangles all stuck together. Cylinder, Pringles all the time. Triangle prism, Toblerone, and then sphere football. Just think of it as being in real life. So hopefully we're going to have more questions. We've got basically formulas here. It's not, again, you won't be given you won't be given that, as in like you'll be given that formula, you won't be given that question to work out. Although on Pearson there is a question that has find me a sphere of a circle, and we're going to have a look at it in a bit. And then triangle, yes, we know how to work out the volume of a pyramid. We've got the area of that triangle, so base times height divided by 2, and then multiply by the length of the triangle, or the length of the Toblerone. So quite straightforward when it comes to breaking shapes down. Breaking shapes down, we did a breaking down of question 3 on atom assessment 2. We broke down to find out the surface area of that cylinder and the tube of Pringles. The volume is just as easy. We think, oh, how am I possibly going to remember how to work out the volume of a cylinder? Well, base times height. Okay, we've got the circle, as in the circumference or the area. Yeah, we need the area. We don't need circumference because that's when we lay it on flat and we're working out the surface area. If we're thinking about the area of a circle, so the lid, that is the area of one of my faces of my shape. Then I need to times it by the base or the height of my shape. So it's area times by the height or the base, we're going to call it when it comes to your shape. And like it says there, it's a cross section. So split it in wherever you want to split it, and that's the area. And then times it by the length. So the actual volume of a cylinder or a triangular prism are not as difficult as what people kind of imagine. It's really straightforward. Find me the area of your face that's looking at you and times it by the length just once, and then you're done. Nets, often a one-pointer. It'll show you a picture of a net. The one that most people have got wrong in the past has been this one here. They haven't recognized that if I take my cylinder apart, I've basically got 2 circles either side of a rectangle. They can't visualize it. So hence why I flip out of my Pringles example to my packet of Rolos example. My 2 little ends of my Rolos. Okay, it's not like the little gold wrapper that's on the end. That's my circles. And then my bit here is when I've unwrapped. No, I've not torn it. I've literally done it really carefully, and I've unwrapped my whole Rolo wrapper, and I've got a rectangle wrapper. So that's my rectangle Rolo wrapper, and that's my 2 little gold ends. So yeah, the net question. Basically, you got to think of it, right? If I had that as a net, if I put it together, what shape would it be? And lots of people can't visualize that turning into that because they don't wrap that long edge around their circle. Oh, that's a weird shape. That can't be any shape. That one's quite straightforward. People can see that it's a box, and that's my lid. Like wrap, lid. And then that one, I think, is just as easy. Your triangles come up and the two flaps come up, so it's like a tent. There you go, like a tent. But I think, yeah, the one that is most, it's not very common in any exam, but they'll often use that one if they're going to use one at all. And it's a cylinder one. So be mindful of a cylinder looks a little bit different in the fact that it's odd circles with a rectangle in the middle. Okay, hopefully we'll get some questions. Right, we've got some questions here. If anybody wants to shout out or anybody wants to kind of like help, then please feel free to do that. These questions are taken from any exam that's out there in the domain of public. It's some are from NCFE, some are from Pearson, some are from City and Guilds, but these are the workshops that I do for my weekly group that's not adult, not ASF, but my weekly study program group. So the ones that are doing their apprenticeship that have to kind of attend every class for 12 weeks, and they have an exam at the end of 12 weeks. And this lesson, so this workshop, or this what do you want to call it, this PowerPoint, it's a 3-hour lesson, and it's really hard to engage people for 3 hours, whatever topic you're doing. But 3 hours for maths, it's really difficult. So what I would do in my 3-hour lessons, because sometimes they're all at home, I say, right, go find me a box out of your cupboard, or go find me a tin of soup out of your cupboard, and they'll bring like a cylinder to the screen, and we'll work out the area of the cylinder, or get a box of cornflakes out of your cupboard. Oh, I've got Weetabix, so I try and get them up off their seat and go in and get things from me. But I'm squeezing a 3-hour session into, not squeezing it, but I'm doing it into an hour, because I'm not covering, I'm not making you all kind of like get your tin of beans and tell me the surface area and the volume of your tin of beans, and then waiting for the next person, because I don't think that's ultimately that productive. But it's getting that feel for maths when I get them to do it. Okay, so we've got James has a contract to paint 30 identical water tanks. He has to paint the inside surfaces of each tank. Each surface is a rectangle. James knows that 1 tin of paint is enough for 12 meters squared and costs £26.99. Work out the total cost of tins of paint he will need for 30 water tanks. Right, have they got lids on? James is going to paint 30 identical water tanks. He has to paint the inside surface of each water tank. I'm not thinking, that question doesn't give me lids, so I'm not doing a lid. So I'm literally going to paint the inside of the box without the lid. So I've got some faces to paint here. I've got one face here and the matching one at the back. So I want to put a little 1 here and a 1 here, because they're the same. So my number 1 face is, I can see it's 1.1 meters, 1.1 times by the distance downwards. So that part there is 0.6. And I've got 2 of them, because I've got the one at the back as well. So I'm times that by 2. Okay. I've got my side face. So I'm going to label that 2. I'm going to label that one 2. I want to put it down there. Okay, that's not to be mixed up with that one. That's this one. So I can see that one. So side number 2 is 0.8, and it's times by the same height as 0.6, and I've got 2 of them as well, times 2. So I've now got my 4 sides that make up the edges of my water tank. I've got to paint the bottom as well. So the bottom, there's only one of them, because I'm sure I'm not painting a lid, because it doesn't look like it. It doesn't look like it's got a lid on it, but let's work it out without a lid. And I know if we get it drastically wrong, because we're miles out, well, then we've got to add a lid on the top. But I don't think that's got a lid on. So the base 1.1 times by 0.8. And I've only got one of them, so I don't have to times it by 2. And I'm going to put all those in a line, add them up, and that's my that's my surface area. So if I add all those up, get a calculator back out. Where's it gone? 1.1, 1.1 times by 0.6 times by 2. 1.32. 1.32. Then we've got the second part, 0.8 times by 0.6 times by 2. Okay. 0.96. 0.96. And the last one, 1.1 times 0.8 equals 0.88. 0.88. Add them all up to find out the surface area. Add 0.96, add 1.32 equals 3.16. One box. He has to do 30. Okay, so we need to multiply that number by 30 for all the tanks he's doing. Times that by 30. We've got a total space to paint of 94. What has happened there? Why has it done that? 94. That's giving you the tips. 94. Oh, what was there? 94.8. Okay. Meters squared. 1 tin of paint covers 12. So we need to divide our total by 12. So that's how many times 12 fits into our total distance, our total surface, divided by 12. So we need 7.9 tins of paint. Obviously, B&Q, here we come. We can't buy 0.9 of a tin, so we need 8 tins of paint, and we need £26.99 per tin of paint. So the cost to do that job is 8 times £26.99p. That's £215.92. £215.92. Just for the materials, not labour. Let's have a look, and I'm sure it'll be right. So there we go. My exam tip there was look how many tanks. I think I've got a mistake. I think I've done it before where I've seen the candles, and it's 50 candles. I'm like, oh, 200. I can't remember one of it, and then the cost. So hopefully, there we go. We've got the same sum as what I did. 1 times 0.6 times 2, 0.8 times that, and then one lid. Total shape, surface area of the shapes. How much each tin covers on 8 tins. So we broke it down, and that was a 5 marker. And you can kind of see here where I'm getting the marks from. We've got the marks are working out the surface area. We times it by 30 to work out the total, like the all the 30 tanks. Then the number of tins rounded up, then the cost. So break it down into 5 marks. A tricky question because we've got a pentagon, 5-sided shape. And as you can see, there's a lot of writing here. So instantly, as a person that focuses on numbers, I'm looking at this number, I can see this number, I can see numbers on my diagram. But apart from that, I'm thinking, oh my God, what have I got to do? What have I got to do? 2 faces at each. So here's a diagram of a doll's house that Jaden has made. 2 faces are each in the shape of a pentagon with a vertical line of symmetry. All other faces are rectangular. The base angles of each pentagon are right angles. So that means that we've got squares, as in like we've got proper, we don't have to kind of change any of these measurements. Jaden wants to cover all surface of the doll's house with paint. He knows that the total area of the base and the roof is 1.8 to 1.3824. So he's done the roof, he's on that side, and he's done the base. Jaden has enough paint to cover 3.5 meters squared. Has he got enough paint to cover? So we know we've got 1.3824 already worked out for us. And that's the roof and the base. So we've got this one and this one to work out, and then this one and this one. So we've got the two sides. So let's go 0.96 multiplied by the height 0.63 times by 2. That's that and that. Now we've got some tricky bit here. Look, we've got to work out the bit where it's got the triangle as well. So I'm going to split it into two shapes. I've got my square, and then I've got my triangle. So I'll do my square first. 0.7 times 0.63 times by 2. That's my two squares. Now I've got my triangle. So triangle, base times height divided by 2 is the area of my triangle. I've got my base written here, look. So that's all right. 0.7 times by, I've not got my height, but I can see to the edge of my roof it's 0.63, and then right the way up to the top of my house, my apex of my house is 0.75. So 0.75 minus 0.63 is 0.12. That's my triangle. Divide by 2 equals, and then I've got to times it by 2. So I shouldn't really need to divide it by 2 and times it by 2. So you don't have to actually divide it by 2, but it's just process. Area of a triangle is base times height divided by 2. I've got 2 of them, so I need to times it by 2. I am not saying, oh, let's not divide it by 2, because when it comes to another triangle where you've only got 1, you think, oh yeah, I don't have to divide it by 2. So the reason I've said divide by 2 here is because that's the process to find out the area of a triangle. And the reason I've said times by 2 there is because there's 2 triangles in this question. Not to confuse anybody. Let's work out all those measurements. 0.96 times by 0.63 times by 2. Oh, that didn't go in right, did it? Did it? Did that work properly? I'm not so sure. I think did I press a different number there? 0.96 times by 0.63 times by, oh yeah, I did, times by 2. Okay, it did work. So we've now got some numbers going on here. We've got 1.2096. Next one is the 2 squares at the ends. 0.7 times by 0.63 times by 2. So that's the 2 square parts, not the triangle. That's 0. Did that last time, didn't it? 0.882. Yes. And then the triangle parts. So we've got the base of our triangle 0.7 times by the height of our triangle 0.12 equals divided by 2, because it's base times height divided by 2 equals 0.042 for each triangle. We've got 2 triangles, so we need to again times it by 2. So it looks like we've got in a circle. We haven't. It's following a process to work out the area of a triangle, and because we've got 2, we're back to the number we had earlier. So we've now got our measurements. We've got the triangles, which we'll start with, add on to the squares, 0.882, add on to the 2 bigger rectangles, 1.2096, add on to the bit that they gave us, which was the base and the roof of this number at the top, 1.3824, and we've got 3.558. 3 what? Oh, I don't want to go 3.558. So 3.558 meters squared. Meters squared. If we look at that, now it's close. Put a bit of thinner in it. Maybe I'll get it done, but he's not got any thinner. He has to have 3.5 for this question. He needs 3.558. Has he got enough? Answer for the 6th mark is no. And for 6 marks, I'm comfortable with that because we've not got any. The most difficult part of that question is working out the area of a triangle. And It's nothing that we haven't done several times where it's base times height divided by 2. Okay, we then times it by 2, so that might confuse a few people, but think of it as being a process of how to work out the area of a triangle. I've got 2. How to work out the process of finding the area of a rectangle. Oh, I've got 2. So we're doing the second part of the maths question because there's 2 of, not because it's part of the process of finding out the area. It's because there's a 2 of that area. So there's no other reason we've done the times by 2 other than there's 2 of them. So the process is here: base, length times width, length times height divided by 2. Done. So 6 marks. There's no. It's no. Right. Have we got another question? I do put exam tips on, so again, I'll show you what you don't have enough paint. Okay. Oh, yeah. One of my favorites. Go, Viv. Go, Viv.
You've changed the picture. I wanted to add something on the one you just finished now.
That one?
Yeah. So when you were doing the triangle, yeah?
Yeah.
You did the base, understandable. The base down is the same as the one on top. Okay, so the height, you deducted it from the 0.7. How about this 0.37? Is that not the height of the triangle?
No, if I've got a triangle. So let me get on. Can I get okay? I got a bit more space here. Okay, my triangle. So I've just done that part here. That's 0.7.
Yeah.
That is 0.37, and that is 0.37. That's not the height. My height is from here.
Okay.
So that's why I've got to go the full height.
Okay.
So yeah.
Yeah,
so I got,
makes sense. Now, yeah, I understand now.
Yeah, it's so that's and maybe that's why it's a 6 pointer, because think, oh yeah, look, I've got my base there. Oh, and I've got my height. I can use those 2.
Confusing, yeah.
Yeah, it can be. Right. A question that is very similar to the I don't want to work it. It's very similar to the one that's about the tube of Pringles. It's not algebra. Oh, it's got letters in it. It's not algebra. It's given you already. It's substitution. It's not asking us how many y's it is. So using y equals 11, calculate the area of the curved surface of the cylinder. It doesn't want the lid of the Pringles. It wants the flat part. When we've undone our Rolo wrapper, it wants the flat part of the Rolo wrapper. And it's 11. Okay, it's telling us that is 11. Okay, so 3 times y is the diameter. So diameter equals 3 times y. 3 times 11 equals 33. So the reason it's putting a number in there, a letter in there, it's just so it's substitution. You're able then to substitute that letter out and put a number in. And the height, okay, the height is y, and we know that y equals 11. So as easy as that, we've got rid of any letters that were in there in the first place, and we've now got just numbers. To work out the area of the curved surface, well, the curved surface, we know, okay, we've got the curved surface there. If it was the area of that curved surface, it's pi times radius squared. It's not asking us for that. We've got to make it the crust of the pizza, pi times diameter, because we're unpeeling our wrapper to make it into a square. That length here is that length all the way around. So that is the circumference each time. It's not 33, okay? As in, like, it's not the same, oh yeah, look, 33 times 11, that's your answer. No, that's the diameter. That's showing you the whole width of that circle. Our diameter is 33. And it's saying the height, okay, we've got that now, 11. So we're now getting closer. We've got circumference times 11. We haven't got circumference yet though, but we do know that diameter is 33. And we do know that when we're using pi, we use 3.14. So now we've got everything we need for this question. We've got all the numbers. So we've got our diameter and pi times by 33. 103.62. So we know that is 103.62 because we've just done that. That's 103.62. And we've got our height. So basically, once we've got the circumference of the cylinder, the distance right around the outside when we've unwrapped it, so it's now flat on the floor and it looks like that, that's 103.62. Times that bit by 11. And we've got 1,139.82, and it's centimeters squared because it's asking us for the area, what it all covers, you know, how big the Rollo wrapper is, not the distance around the outside. That's circumference. That's one measurement. We needed the circumference to then work out what the part was. So hopefully by doing that question, or if you look at this one back, it'll give you a big foot up for the question 2 on that's been rounded up. I'm thinking that's a different answer. He's rounded it up. That's been rounded up to, what is it rounded up to? Have they used pi? Have they used the pi button on a calculator for that one? Maybe I think they've used pi button on a calculator because we've maybe rounded it up. I'll go back. Have they rounded it up? Yeah, they've rounded it up a little bit. That's 0.4, 103.63. So they've used pi. They've used pi as a different, not a different number, but they've not used 3.14. For NCFE, it tells you specifically to use 3.14. So that's where we got that one from. The biggest question, and we're not going to have time for this one, which is a shame. And it's only a shame because it's the volume of a sphere. On NCFE, I've never seen work out the volume of a sphere. Never. On Pearson, I've seen it once, and that's in what, 11 years. So it is there, but once in 11 years is not regular enough to kind of like really revise that, because A, we're not using Pearson at the minute, we're using NCFE, and B, it gives you the formula anyway. So it's not that much of a difficult question. It's telling you what to do with the question. It's giving you the formula. So it's the math here is not remembering how to work out the surface area of a sphere. It's asking you to follow the formula to work out the surface area of the sphere, and then times it by 45. Because these little sweets, never did like them. Never liked them. So we're not going to do that one. We can have a look at it next time, maybe, if you want. We can have a look for it and have a go next time. And then we've got one more to do. So we've not quite fit it in, but I don't mind we haven't fit them all in, purely because I want to make sure that what we're doing is relevant to the questions that you're on in Atom, if you're looking at this section, or if you're looking to get exam prepped, that you're comfortable doing area and perimeter of a squarey shape or a cylinder. Those are the two big ones that you need to be comfortable doing. If you're comfortable doing the squarey shape, so the square with another square on top and working out, splitting it up to two, great. If you work it as one big one and take away the little space, absolutely fine as well. And then the surface area of a cylinder, picture it as a packet of Rollos, my brown wrapper, my two little gold bits, or Pringles, the plastic bit that comes off the top. I don't mind what you think of it as. You might have the favorite food that's in the shape of a cylinder. And again, this one isn't a difficult question because it's telling us what the area of a trapezium is. So the difficult parts, the bit on the front and the bit on the back, it tells us. The rest of it is 1 times 1.4, 1 times 1.4 times 1 times 1.4. So really 1 times 1.4 times by 3. is the bits that we have to work out, we're having knowing, and then they give you that area for that one anyway. So yeah, to me, that sort of question for 4 marks all day long. Hopefully you've got something out of that. If you're wanting to go back to doing like oh my god, my brain's not thinking straight, the past papers because you're ready for an exam, absolutely we can do that. I just thought I'd start looking at some of the units where I felt people were asking me lots of questions. So over the weekend, this weekend, I probably got 2 or 3 surface area volume questions asked. And I know you might think, oh, it's the same people that come to the workshops all the time. Absolutely, that's fine. But the other people that may be working on Atom or working on BKSB or working somewhere and sending me questions about volume, surface area. So it's just a case of trying to make sure that when I'm getting not requests, and when I'm getting people with regular problems, that I can actually demonstrate when I send the video by watching it can help them. Any questions? I'm going to stop sharing. I'm going to stop recording. What would you like to go through tomorrow? Any